Okay, so this is part number 2, uh, exercise 7 in page number 92. A rhombus whose side length is 4 centimeter and the measure of one of its angles is 60 degree. Find the area. So one of its angles like this, one of its angles like this one is 60, and as we know, the diagonal bisects the vertex angle, which means this one will be 30 degree. Okay, and the other one here is also 30 degrees. Okay, so what do we have here? We have two diagonals, and as I said before, they are perpendicular, which means we have here 4 right angles and 4 right angle triangles. Okay, so let's focus on one of them. Okay, so let's focus on this one. So this triangle here, it is right angle triangle, and it has an angle of measure 30 degrees, which means this one we can call it a 30-60 triangle. And there is given that here it is the side length is 4, so this one is 4, and because this is a rhombus, so all sides are equal length, each one of them is 4 centimeter. Okay, so in this triangle we will focus on this. We have right angle triangle and we have a measure of angle 30. In the right angle triangle, the side that opposite to measure of angle 30 degrees, the side opposite to this angle is half length of hypotenuse, so it is 2, and this one also is 2. Okay, so focusing on this triangle, we have here right angle triangle and we have 2 side lengths. How can we get the third? Yes, excellent. To get this side, we'll use the Pythagoras theorem. Pythagoras theorem says that if you have 2 sides in the right angle triangle, you can get the third, because here we have the hypotenuse, and the hypotenuse is the side that opposite to the right angle, so we will make subtraction. 4 bar 2 minus 2 bar 2, and use calculator to calculate it. It is 4 bar 2 is 16 minus 4, it is 12, so 12 square root of 12 is 2 root 3. Okay, so the answer is 2 root 3 centimeter. Okay, so we have here this one is 2 root 3, this side, and because the diagonals bisect each other, okay, so this is 2 root 3, and as we said before, this one is 2 and this one is 2 also, because diagonals bisect each other, and this one is 2 root 3. Okay, so now we have the length of the 2 diagonals, so to get the area we will multiply half by diagonal 1 by diagonal 2, half by 4 by diagonal 2, which is 4 root 3. Okay, so because we multiplied by the whole diagonal, not the part of it, not the half of the diagonal, no, by the whole diagonal, so half by 4, it is 2, 2 by 4 root 3 is 8 root 3 centimeter square. Okay, so this is the final answer, centimeter square. Okay, is it clear? Okay, so let's go to the next page. The next page is talking about the area of the trapezium or trapezoid. So as you see here, this is the trapezoid or the trapezium. To get the area of it, we multiply the middle base by height. Okay, so this half by base 1 plus base 2 is called what? Is called middle base. Okay, so to get the area of the trapezium, we will multiply half by base 1 plus base 2, which is the middle base, by height. Okay, so again the rule here, middle base is half by base 1 plus base 2. So the shaded part here, okay, or the marked one, is the middle base, half by base 1 plus base 2. This is base 2 as you see here, and this is base 1, or the converse, they are the same. We can make it p1 here and b2 down, they are the same. Okay, so to get middle base, which is this one, we will do what? We will multiply half by base 1 plus base 2. Okay, so what is the meaning of isosceles trapezium? Isosceles trapezium is the trapezium that has two opposite equal sides. So these two sides are equal in length. And by the way, the trapezium, it is a quadrilateral, which means it has four sides, but it has only one property, which is two opposite parallel sides. Only two sides are opposite to each other, are parallel. This is the only property for it. But isosceles trapezium, it has another property. These two sides, as you see here, these two sides are equal in length, and these two angles, measure of angle B equals the measure of angle C, and measure of angle A equals the measure of angle D. Okay, so these are the properties of the isosceles trapezium. And it also has one axis of symmetry, which the axis of symmetry, as you know, is the straight line that divides the base, divides the figure into two congruent figures. Okay, so like this one, this is the axis of symmetry of the isosceles trapezium. Okay, so let's go to example number 1. A trapezium in which the length of two parallel bases are 7 and 9, and its height is 5. Find its area. Okay, so we'll use the rule directly. Okay, so the rhombus, the side length, I'm sorry, it's not this one, yeah, this one. Okay, so we will multiply half by base 1 plus base 2 by height. So base 1 and base 2 are 7 and 9, 7 and 9 by height, the height is 5. Okay, so the answer is what? Half by 7 plus 9 is 16, so 8 by 5 is 40 centimeters square. Okay, let's go to example number 2. A trapezium in which the length of its middle base is 8 and its height is 12. Find its area. Okay, so example number 2. The trapezium which the length of middle base is 8 and its height is 12. Find its area. So the trapezium, the area of it is half by base 1 plus base 2, which is, yes, excellent, this is the middle base. So we can make it like this. The area of the trapezium equals middle base by height. So middle base here is 8 and the height is 12, so 8, I'm sorry, and the height is 12, so 8 by 12 is, it is not 18, it is only 8. So 8 by 12 is 96 centimeters square. Okay, is that clear? Okay, so let's go to example number 3. A trapezium whose area is 126 centimeters square and the length of the middle base is 21. Find the height. Okay, so we have the area and we have the middle base. How can we get the height? Excellent, by dividing. So we will divide 126 over 21, which is 6. Okay, so in example number 3 here, we can use the magic triangle. So we'll divide 126 over 21 and the answer is 6 centimeter. 6 centimeter. Okay, so let's go to example number 4. A trapezium whose area is 63 centimeters square and the length of one of its two parallel bases is 8 centimeter and its height, I'm sorry because we have a mistake here. Okay, so and its height is 9 centimeter. Find the length of its other base. Okay, so let's go to example number 4. So what can we do here? We will use the magic triangle to solve it. Okay, and when you use the magic triangle, we have here to get the other base. Okay, so use the magic triangle and try to solve it, and tell me the answer. Okay, goodbye.